Hi, this is Mr. Manley. Today we're going to take a look at the quadratic formula. The quadratic formula is a technique that we're going to use to solve an equation. Now, hopefully that you understand that solve often means, though not always, that we are setting an expression equal to 0, and we're trying to figure out what value of x will make this expression come out to 0. Now, something that we've done with this in the past, that you may have done with this in the past, is that you've tried to factor it. So if I set up a FOIL, and let's just say I was going to try to do this maybe with a +1 and a -2. All right, so we know that's not going to work, but let's just look at it, and then if we were to check it, we'd get 5x squared minus 2x plus 5x minus 2, and then the problem is that we've got the 5x squared, we've got the minus 2, but here we've got a 3x. Minus 2x plus 5x is 3x. We need it to come out to 4x. And the fact of the matter is that I'm not going to be able to factor this expression. And this expression is quadratic. What makes it quadratic is that I have x squared, and that is the degree of the expression. So the highest exponent is going to be 2 to have a quadratic expression. Now, if I have a quadratic expression and I'm trying to solve it, set it equal to 0 and solve it, and I cannot factor it, this is where the quadratic formula comes in. Now, the quadratic formula is going to be used when we've got a quadratic, and the quadratic, we want it to be in this form. Now, what do I mean by this form? Let's just take a look and see that we could have a quadratic that's in a different form. So this down on the right here, this is quadratic as well, but it is not in the ax squared plus bx plus c form. Now, I could put it in that form if I wanted to. Begin by foiling the x minus 2 squared, and then from there I could simplify, and would I have 2x squared minus 8x, and then plus 8 plus 7 would be plus 15. Now it is in the form ax squared plus bx plus c. You see this? See how that is similar to the upper right hand corner, which is the form that we need for the quadratic formula. All right, so, but the point here mainly was that we can have a quadratic, as we do here, that is not in the form that we need in order to be able to use the quadratic formula. But the one that we're working with is. So let's go ahead and back and focus on that. So back to this equation here. We've got 5x squared plus 4x minus 2. Now we're just going to match it up, kind of a one-for-one matchup here. All right. So the 5 is A, and the 4 is B, and the minus 2 is C. And then we're going to substitute those values into the quadratic formula. And the way that I want to write this is, remember, the whole purpose here, going back to this, is that I'm trying to solve for x. I'm trying to figure out x, what does x equal in order for this to come out to 0. So I'm going to write x equals. That's what I'm trying to find out. Now, what does it equal? It equals this negative b. So look at the quadratic formula up to the right. So that I need the negative b. So that is this 4 is my b, and I want negative, or the opposite of that. So that'll be negative 4, and then I get this plus or minus. This is something that you don't deal with very often, and it just saves us time. Instead of writing out, look at the plus minus there, the plus minus here. Instead of writing out two separate expressions, and one using the plus and one using the minus, I just write it as a single expression, plus or minus. At the end, I'm probably going to break it up anyway, but for right now, it'll help condense things. Next is we have the radical up here. So I'll do the radical. And then I want b squared. So I'm on b squared. And that's this 4 being squared. So I'll go b squared minus 4. So I'm on this 4 here, if you look at the quadratic formula. And then I'm going to go AC. And there's my A, if you look back at the original equation, and there's my C. The 5 is A, and the C is negative 2. So we'll do those two substitutions. A is 5, and C is negative 2. And then that'll be over 2 times A. So there is the quadratic formula, and these are solutions to the equation. A little problem here is I want to simplify it, right? So we're going to have to work with radicals a little bit and try and get this simplified. So we've got this 16 from the 4 squared, and then we've got this plus 40 from this, because I have a negative, so that gave us a positive here, and then 4 times 5 times 2 is 40. And in the denominator, 2 times 5 is 10. We can simplify a little bit further here. So I can go negative 4 plus or minus the square root of 56 over 10. Simplifying the rad 56 would be a good exercise for you. So you could pause and take a couple of moments to do that, because that's something that you've probably been required to do recently. And there is the simplifying of rad 56. And then we can factor out a 2 and simplify further to this. Right, so that's factoring out a 2 and canceling a 2. I think I could easily see somebody make an error where they just go, oh, I'm going to cancel that and make that 5 and cancel that and make that 2. But that would be incorrect. When you have this 2 terms up here, you would have to cancel with every term like that, or that would be 1. So that would be 1. So we could look at another way of thinking about it is that you're factoring out a 2. So if I take that and I factor out a 2, and I have negative 2 plus or minus, and then that continues, and then I'm canceling that 2. Okay? So you want to be sure you understand that and don't make that error, because it'll come up a lot in these quadratic formula problems. So as of right now, we have this. I do want to address this just a little bit further. That is the solution of what x equals. So we were solving for x, and that is our solution. X is equal to this. But let's just break that down a little bit more. So let's just look at what does it mean that I've got this value of x equal to negative 2 plus or minus rad 14 over 5. The first thing is that there's 2 solutions here. There's negative 2 plus rad 14 over 5, and there's negative 2 minus rad 14 over 5. So that's what this plus minus means. It means that I've got 2 of these, 1 and 2. One where I do plus, one where I do minus. The other thing is just to understand, just to reflect that look, what this all means is that if I take this and I substitute it for x here and here, this is going to come out to 0. Now, we're not going to do that, and you don't need to do that, but understand that's what it means. The other thing is to just consider that what is this? It's some number, and this is the exact number that it is, negative 2 plus rad 14 over 5, but that's not really the most convenient way to look at that, right? We might say that this is something approximately. So it's approximately some value. If I take the 14 and say, well, that's something between 3 and 4, right? The square root of 14 is something between 3 and 4. And if I said that is -2 plus something between 3 and 4, so maybe it's like -2 plus 3.5, and that, what would that be? That would be like 1.5 over 5, and then I could further approximate that. 0.3 would be so that, and that's all approximately. And this is not anything that we do with this problem. I just want to point out that this is a number, and the number that it is approximately 0.3. And if I plug that in here, if I did 0.3 squared minus 5 times 0.3, it's not going to come out to 0. But it's going to come out close. I've just done an approximation. I just want you to understand that when we are working with these radical expressions, that these are actual numbers that have some value and that are concrete, and they're not just some symbols mashed together with a radical, and you're not really sure what that means. It means it's some number, and it's some number that would get plugged in here and would make it come out to 0. Okay, so just one other thing that would come up with imaginary numbers that I would like to, or not with imaginary numbers, that would come up with the quadratic formula, is that we could get imaginary numbers. So if I take a look at this one, I think, oh boy, that whole discussion I was talking about the wrong, all right, so this here, I miscopied it. So I miscopied that here. So on this whole page here, I should have been talking about 5x squared plus 4x minus 2 instead of 4x squared minus 5x plus 3. I don't have an easy way to correct that on the video, which is one of the disadvantages of video, but I'll correct it now. So this was 5x squared plus 4x and minus 2. Minus 2 equals 0. So this whole discussion over here was related to that. So if you noticed that the expression changed here, that, yeah, you did notice an error in the discussion, that this was not what we were talking about. Actually, this one I want to briefly address, this 4x squared minus 5x plus 3. So let's take that forward. See, this is where I thought I was. All right. So 4x squared minus, what was it, 3x? No, 5x. Minus 5x plus 3 equals 0. Now, if I solve this for x, I'm not going to be able to factor it. And if I solve it and I go negative b plus or minus b squared minus 4ac over 2a, what you see here is this, what's going to happen, 25, that's going to be, this is going to be 25 minus 48. And do you see what's going to happen there? It's going to come out negative. And then what are we going to do? We're going to have a negative, rad negative 23, and that is imaginary. So you do want to be heads up on solving with the quadratic formula, that you will sometimes come out with an imaginary solution.